Hey guys, welcome back to the engine room. My name is Dex, aka the Binary Machinist, and I'm a working data engineer. This is the second video in the engine room series where I teach data engineering concepts by building data pipelines. Today we're going to get a little bit deeper into Mercury, which is an open source Pythonic toolkit that I built to help me do my job better and faster. We're building a very simple ETL pipeline, and we're using the xfile utility from Mercury to take a source CSV file and transform it before loading the records into a target data store. In the last video, I demonstrated a transform where all we changed was the field names of the inbound records, and that was simple enough using Mercury that we didn't need to write any code. In this video, we'll go a little bit deeper and get into some actual coding. So to follow along, you can visit the Binary Machines GitHub. There's a link in the description, and clone the mercury-demo repo. If you've already cloned it, just pull the latest changes. The dependency files are there for you, requirements.txt if you're using pip, and pip file if you're using pipenv like I do. So if you're already in a virtual environment, you might do pip install -r requirements.txt, or you would, if you're using pipenv, then you would say pipenv install, which I've already done, and then you'd say pipenv shell. Okay, so I'm in the virtual environment. The dependencies are loaded. We're good to go. Let's go into the module directory. This is xfile 2. We're in xfile module 2. Okay, so let's take a look at the input file. Actually, let's take a look at So the input file, the source data file, is a little bit different from what we used last time. It has some additional fields, okay, that we'll deal with. I think the last time we just had everything up to zip code, and now we've got email address, subscription status, and so on. So we'll deal with those fields. Taking a look at the init file, we see that it's pretty much the same as it was last time. No mention of the new fields. So before we make any changes, let's just run this transform, okay, and see what we've got. Okay, so again, we can run xfile by itself, give us the usage strings, xfile --config extract test2.yaml, delimiter is pipe, the map is called test, and the data file is called test2.csv. Excellent. So xfile has told us that we need to set an environment variable, and again, if you remember from last time, that is because we told it that the project home is mdemo home. The $sign means this is an environment variable. We haven't set that. Let's set it. And let's just set that to the current directory. Okay, now let's rerun the transform. There we go. Okay, so xfile has just ignored the extra fields, which is what we want, right? Xfile doesn't care about it because we haven't told it to care about it. So now let's start to add some things here. Let's do get some split screen action going. Okay. So actually, I don't want to do that. I want to do it the other way. Split left. Such a pain. Okay, there we go. All right. So if you remember from last time, when we transform field names, right, we're doing very simple changes here. We're gonna specify the output field name. So we have new fields. Zip code we already got. Email address is next. So we're gonna call that email, right? That's the name of the field in the output record. The source of the data for that field is the inbound record. So we're calling that record, and the key is email. Excuse me. Okay, and let's do the other ones while we're here. All right, so let's Okay, so email, what's next? Subscription status, sign up date, and expiration date, right? So 1, 2, 3. Right? So let's call subscription status status. And let's call sign up date start date. And let's call the expiration date the end date. Okay. Okay. So that should be good. All right. Save that. Let's run the transform. Okay. So there we are. We have successfully transformed all the field names, and now we're reading all of the fields in the source data. Let's just pipe that through JQ. I strongly recommend that you install the JQ utility. I'll put a link in the description for that too. It's a convenient way of wrangling JSON at the command line. Okay, so JQ will just prettify the output. Okay, so this is what we want for a first approximation. Now, let's start dealing with some of the content in the fields and in the new fields. For example, we notice that the status line, okay, the status record, the contents of that record are capitalized, right? Paid, suspended, lapsed. I don't like that. I want all these words to be all lowercase. Okay, so we can do that using the xfile Lambda functionality. Okay, I've put some functionality into xfile such that it can generate allow you to specify Python lambdas on a per field basis. Just small bits of logic that you can use to transform incoming data. So let's take the status and make that lowercase. And to do that, we're gonna call the source, instead of the source of the data for this field being the inbound record, the source is going to be Lambda. Okay, and then we're going to say that the expression, the actual Lambda itself, right? We're going to say that is the inbound field transformed to lowercase. Now, inside the an xfile Lambda expression, it's more like a Lambda template that gets expanded at runtime by xfile into an actual full-fledged Python Lambda. So we inside that expression we use tilde to designate a variable, a tilde prefix to designate a variable. So it doesn't matter what the variable name is. This Lambda will have only one input variable, that being the input value, and that being the value of the field, the incoming field. So we can call this whatever. Let's just call it x, and we know it's a string, so we can just say x dot lower. That's it. Okay. Let's save that and run it. Okay. So now the contents of the status field are all lowercase, which is what we want. Right? Now we can do more sophisticated things with this. Let's play around a little bit. Let's say that we're going to take the start date and the end date, right, which are just strings, but they're strings delimited by a slash. Okay, and let's just say that we're going to tokenize those and turn those into arrays of integers. Let's say that'll make it slightly easier for us to turn those into dates. All right, so we can say the start date is a lambda. The key is still the same. The expression is going to be, we can do a list comprehension. We can say int token for token in the incoming value, that incoming string, dot split like that, okay? And we'll do the same thing here. We'll say this is lambda, and the expression is the same. And again, we can change the variable name if we want. If that's a start date, we can say SD. End date, we can say ED. It doesn't matter as long as you've got that tilde prepending it. It knows that this is the inbound value. Okay, so let's run that. Okay, and there we have it. Right, we've transformed the start date into an array of strings: month, day, year. Okay. Excuse me, an array of integers, right? Month, day, year. Okay, so that's cool. Let's see what else we want to do. Let's say that our requirement for this data pipeline is that the records that we land in the target data store also have to have a computed value. Let's say that they want us to provide the number of days that someone has been a subscriber. Okay. So, we have the information here. We know, when they signed up, we know what their status is, right? We know the expiration date of their subscription. So we have everything we need, but of course, there is we can't read the information directly from the record. We have to compute it. So, and that's often the case when you're writing data pipelines, okay, and doing these data transforms. You have values that are intrinsic in the data, and you have computed values. So let's do a computed value. Let's call this, let's generate an additional field called days as subscriber. Okay. And to designate this as a computed value, what we're going to do is we're going to say that its source is lookup, right? And that's it. That's all we need to do, right? At least to designate it as a lookup field. Now let's see what happens when we try to run this transform. Very good. We got a nice clear error. No such lookup method. Right? So we've registered a data source, test data source, but xfile is telling us that it has no lookup method. Lookup days as subscriber. So, why does it think it needs that method? Because by default in xfile, any field with a designated whose source is designated as lookup, by default it wants to find a method on the data source class called lookup underscore target field name, and here the target field name is days as subscribers. So it's going to try to look up that method. Where's it going to try to look for that method? In the lookup data source. Which lookup data source? It's the test data source, right? That's its alias. The actual class is test data source class. And where is that class? It's in the data source module. So let's take a look in there. Okay, so that makes sense. We have a test data source, but the function that we have in here, so the method we have in here is called lookup longevity, not lookup days as subscriber. Okay, so we can override that default logic in xfile just by saying, instead of saying that the source is lookup, we can say the source is lookup underscore longevity. Now, the reason I built in that override is because you may, in fact, I did run across a situation where I had to generate a field, an output field whose name was not, would have made the method name invalid. Like it would, it had, I believe it had spaces in it, and so you can't have a Python method name obviously with spaces in it. So I built in this override such that you could have, whatever the output field name is, it is, and you can point it at whatever function, whatever method you need to point it at. So we've got that. All right, let's just run that transform now. Okay, so now we have a new output field called days as subscriber, and as we would expect, its value is null because we haven't populated it. So right away we can just say print that, right? And now, excuse me, that's wrong. Sorry, not that. We're not going to print anything. We're going to return that. All right. And now let's run that again. Okay, and we see here that days as subscriber is the field that our the value, excuse me, that our lookup method returned. Okay, so let's take a closer look at the workings of this method. We see that we've got some parameters that are passed to us. Okay, and what's that about? Well, the target field name should be self-explanatory. Every field that we generate, you know, obviously we're generating target field, so the target field name is whatever it is for this record. So here we say that let's just print that out, right? Let's just print. All right, so we see what we're doing, right? Field name is okay. Now the source record is just that. It's the complete dictionary that xfile scanned in when it read that record. Okay, and that's useful sometimes. You need to know what you're working with even before you transform it. So we can print that out. Okay, and last but not least, we have the field value map. Now, what is that? Well, the field value map is essentially it's a map of all the resolvers, if you will, in the constructed mapping rule set. What do I mean by resolver? Well, when xfile scans in, well, actually, when xfile starts up and it spins up and kind of constructs its map, right? Constructs the rule set for how to transform a record. Every field that is not designated as a lookup source, okay, a lookup type field, has a resolver associated with it. Right? It's a piece of logic. It's a class that that kind of embodies the rules for doing that transform. And so what that means is that using a field value map, while you're in this piece of logic here, you can find out what the output value for this field would be, for any field would be, without having to go back and consult the init file, and you can generate that value without having to explicitly kind of use this logic again in the data source. So that's a convoluted explanation, but should be clear in a second. Right? If we say field value map, okay? Actually, before we do anything else, let's just run this and see what we got, right? Okay, let's run that. Ah, interesting. Okay, we got an error, which is not an intuitive error. So what's going on here? Well, it turns out, I know what this is. Notice that we scanned 3 records and we transformed 3 records, right? And so xfile is not the problem here. Xfile actually did what it was supposed to do. I recognize this kind of error as a JSON parsing error, which kind of makes sense because we're piping the output of this through JQ. So if we were to not pipe it through JQ, then we'd have all our debugging output, right? And we have our target field name is, right, source record is, it's an order dictionary, and the field value map is this. Again, it's basically a wrapped dictionary inside Mercury. So first things first, let's I like using JQ, so let's set it so that this doesn't happen. We will import sys, and then we will say file equals sys.standard error. Okay. So what this will do is, instead of printing this to standard output, it'll print it to standard error. Why is that important? Because remember that at the command line, the thing that gave us the error was that we were trying to send essentially non-JSON output to a JSON parser, JQ. So everything emitted to standard out from this program, from the xfile utility, was getting fed to JQ. So now the stuff that we're printing to standard error will show up on the console, but only its clean output emitted to standard out will go to JQ. So this should fix our problem, and yes, it does. Okay, so we still have our debugging output here, but all the clean JSON output that we generate goes to JQ. Okay, so that's good. Now, let me just flesh out the explanation of field value map, because it's a little bit important. So we said that, for example, we have certain transforms happening here that are not lookups. For example, these lambda transforms, right? We're actually transforming the value of the inbound field using logic we've specified here. Now, the question is, how do we access that logic? We can access it from inside our lookup method by using the field value map. So let's get rid of that. Let's get rid of that for a second. And let's do print out the source record, and let's just say that we're going to print out the end date, right? So okay, now what we're going to say is that we're going to get the value of that, right? And the value of that is going to come from the field value map. We're going to say field value map dot get value, and we're going to pass it the target field name. In this case, we're going to say end date, right? And we're going to pass it the source record, because it is there is a transform happening on this source record, right? So what this should tell us, and let's just make sure we're writing that to standard error. All right. So this should give us not the raw date string, but the value that we are transforming that date string into. Remember, that's an array of integers, right? So this will fire up that. This will will access that particular resolver and give us that value and print that out as part of our debugging. So let's do that. Okay, and let's scroll up and see and there we go, right? The subscriber end date is, and we get the array, not the raw value. So that's why I pass a field value map into the lookup methods of the data source, so that you can access that logic from inside here. Okay. Again, this doesn't work with fields that are designated as lookup fields, but it doesn't need to, for reasons we'll get into later. So we're good to go with that. So now, again, let's say that we've been given a requirement that we have to find out how long this person has been a subscriber. So here is where we kind of pause, or on a real job, I would pause and get out of my chair and go talk to someone, right? Because the fact is that there are some edge cases that we have to think about, that affect how we calculate how long someone has been in the system. For example, do we? It might be trivial. It might be kind of obvious to say that if their start subscription date and their subscription end date are both in the past, then how long the person was a subscriber is just the difference between these two dates. Okay. But what if their subscription has been suspended? Like, what does that mean? What is a suspension in the business rules of the organization? Likewise, it might be trivial to say, okay, if their subscription end date is in the future, then it's easy to calculate that, but we don't know. It's not something we can discern just from looking at the data. We need to make sure that that things mean what we think they mean, and this is part of I guess you said the art of data engineering, right? Our customers, not the company's customers, but our internal customers, the analysts, the marketing people, whoever is consuming our output, often they have a general sense of what they want, but they're usually not software engineers, right? They're civilians, and so they don't have a lot of practice taking a concept and making it explicit enough so that a computer, which is dumb as a rock, can understand it, right? Or can deal with it, I should say, right? So, and this is very true also, it's more true the simpler a concept is, right? So customer, subscriber, kind of everyone knows what a customer is. Everyone knows what a subscriber is. But the fact is that often the simpler a concept is, the less well thought out it is, because the more everyone tends to take it for granted. Okay, so this is part of what it means to do data engineering, right? We're not just focused on the code. We're not just focused on the systems. We're not just focused on the data. We're also trying to get inside people's heads and kind of become domain experts to the extent we can, so we can give correct answers, right? We can generate correct answers, all right? So this is, I think, a good stopping point, right? We're ready to do the next phase, which is to actually calculate the user longevity, okay? And we've kind of shown a little bit more of the capabilities of xfile. So in the next video, we'll dive a little bit deeper and generate meaningful output from our lookup function or lookup method. All right. So thank you for watching. Please like and subscribe if you thought this video was useful. And all the links should be in the description. Of course, you can check us out at binarymachines.io. So again, thanks for watching, and see you next time. Take care.